Let's take a look at what's known as a limit comparison test. This is very similar to the ratio test in some ways. The idea here is that this particular test may actually be easier than working with these inequalities, because on the direct comparison test I had to work out these inequalities, and sometimes those can be pretty messy. So here's the idea. I want to know if AN converges or diverges, and specifically all my terms are greater than 0, so I have all positive terms. And the idea again is that I'm familiar with Bn, where Bn is also all the terms are greater than 0. So in other words, I know if Bn converges or diverges. I know what's going on there. Now, if both series are changing at the same rate, then they're going to both either converge or diverge together. So the idea here is I'm going to take a look at the limit as n goes to infinity of An over Bn. Remember, An's the guy I'm questioning. Bn is the one that I know about. So if this limit as n goes to infinity of An over Bn equals L, where L is some real number, and if it's positive, it's greater than 0. Now notice I said L is greater than 0, it's a real number. That means it can't be infinite, because infinity is not a real number. Okay, so some real number greater than 0, then An and Bn both converge or diverge together. So in other words, it's really important that we know what Bn does, just like the other test. We need to know Bn. It's a known series. We know what this thing does. So if we know what it does, we can compare it in this way. And if this limit is a real number, a positive real number, then what this is saying is that whatever they're doing it together. So let's take a look at a couple of examples here. 1 over 5n. Now, this looks a lot like the harmonic series. Matter of fact, it's 1/5 times the harmonic series. So I'm going to compare it with, I'm going to let my Bn be simply 1 over n, which I know is divergent because it's a harmonic series. So I'm going to take a look at the limit as n goes to infinity of 1 over 5n over 1 over n, and when I work out this limit, which I'll do one more step, this is the limit as n goes to infinity of 1 over 5n times n over 1. The n's cancel. This is 1/5. That's a real number greater than 0. Therefore, what's going on here is whatever this is doing, it's doing it along with that one. So therefore, this sum n equals 1 to infinity of 1 over 5n is divergent by the limit comparison test. So we actually have two comparison tests right now. We have this limit comparison test, which I just did this example with, and we have the direct comparison test. See, I am directly comparing it with this, but I'm not doing the inequalities. I'm taking a look at the ratio. So these two are actually very similar in some ways. Let's take a look at one more example here. 1 over n squared plus 1. This looks a lot like 1 over n squared. So I'm going to go ahead and let An be 1 over n squared plus 1 and Bn equal 1 over n squared. And then I'm going to take a look at the limit as n goes to infinity of, let's see, 1 over n squared plus 1 over 1 over n squared, which equals a limit as n goes to infinity of n squared over n squared plus 1. Now I need to take this limit, so I would apply L'Hopital's rule, because this goes to infinity over infinity, which is a limit as n goes to infinity of 2n over 2n, which is clearly equal to 1. Therefore, since I know this is convergent, it's a p series of p equals 2, therefore this infinite series n equals 1 to infinity of 1 over n squared plus 1 is in fact convergent by the limit comparison test with the sum of 1 over n squared.